Hello children, good morning to you. So today we are going to start the new lesson, periodic classification of elements, which is the fifth chapter from our textbook. Okay. So in the picture you can see periodic table of elements that we use presently. This is the modern periodic table. Okay. So before getting this periodic table, the modern periodic table, a lot of scientists had made remarkable attempts to classify or to group the elements known at that time. So today we are going to learn history of periodic table. Okay. So this is the history of periodic table. The remarkable attempts made by different scientists are listed here. Among them, the first one was Dobereiner's triads. Okay. And the second one, Newlands octaves. Third one, Mendeleev's periodic table. And finally, the modern periodic table that we use presently. Okay. So let's move to Dobereiner's triads. Okay. So here Johann Wolfgang Dobereiner, he was a German chemist. He tried to arrange the elements with similar properties into groups. Okay. He identified some groups having 3 elements each. So he called these groups triads. Triad means a group of 3. See here, I have taken one triad here. See, lithium, sodium and potassium. Symbol Li, Na and K. So their atomic masses are also given here. Lithium is having atomic mass 7, sodium 23 and potassium 39. Triad means it's a group of 3 elements with similar properties. See here, lithium, sodium and potassium are similar in their properties. One important point which is to be noted about Dobereiner's triad is, he found that the atomic mass of the second element, in this triad, it is sodium. Second element is sodium. The atomic mass of the second element is the average mass of the other 2 elements, first and third element. For example, if you take the average atomic mass of lithium and potassium, which is 7 and 39, you will get 7 plus 39 divided by 2. So, which is 46 by 2, you will get 23. So, which is exactly the atomic mass of sodium. These are the complete table of Dobereiner's triads. He could identify 3 triads only from the non-elements. See here, what are they? Lithium, sodium and potassium. Then calcium, strontium and barium, another triad. And third triad, chlorine, bromine and iodine. So remember, the atomic mass of the second element will be the average atomic mass of the other 2. First and third element. Okay. Now what was the drawback of Dobereiner's triad? Limitations of Dobereiner's triads. The limitation was he could identify only 3 triads from the non-elements of that time. That was the drawback of Dobereiner's triads. So this triad was discarded by the scientific world. Okay. So the next one is Newlands octaves. Come on children, let's move to discuss Newlands octaves. Newlands octaves. Okay. So this picture shows the English scientist John Newland, who tried to arrange all the non-elements of that time in the increasing order of their atomic masses. Remember, atomic masses. Okay. So he tried to arrange all the non-elements of that time in the increasing order of their atomic masses. Okay. Now the word octaves is inspired or taken from music. Let's check what is that. See, this is a part of a keyboard. And we know that in Indian music, sa, re, ga, ma, pa, tha, ni. Again sa is coming, isn't it? Okay. So if you count sa as the first note, 1, 2, 3, 4, 5, 6, 7, 8th one is again coming as sa. That means 1 and 8 are the repetitions, isn't it? Sa is coming as 1 and 8th. Okay, so this will repeat. So here, similarly, like in the case of music, Newland proposed that when elements are arranged in the order of increasing atomic mass, every 8th element repeats the properties of the first element. He called this the law of octaves. Okay, octaves means in the music, Sa repeats again as the 8th note. Okay, this is Newland's octaves. Okay. So, what is Newland's law of octaves? When elements are arranged in the order of increasing atomic mass, every 8th element repeats the properties of the first element. Okay. Now, this is Newland's octaves. Okay. And he found that the first one, if you take the first one as lithium, for example, after the first one, 2, 3, 4, 5, 6, 7 and 8th one is coming as sodium. So, lithium and sodium are having similar properties. Okay. Another one, beryllium and magnesium are having similar properties. So, he made columns to accommodate these similar elements. Alright. Now, we know that the properties of lithium and sodium are found to be the same. Similarly, beryllium and magnesium show similar chemical properties according to the Newland's law of octaves because they are the first and 8th elements, isn't it? Now let's check what are the drawbacks of Newland's octaves, or why did the world of science discarded this periodic table. Now the first one was Newland's octaves was applicable only up to calcium. See here the position of calcium you can see here. Okay. So after calcium what happened? The elements were not obeying the law of octaves. Okay. So that was the first drawback. So here you can see after calcium every 8th element did not possess properties to that of the first element. Okay. Second drawback was Newland assumed that only 56 elements existed in nature. So in his time only 56 elements were known. Okay. And he thought that no more elements would be discovered in future. But later on when new elements were discovered, law of octaves was not matching with their properties, or law of octaves failed to explain the properties of that elements. Clear? Okay. Now we'll move to the next drawback. The third disadvantage is, you can see cobalt and nickel are placed in the same slot, and also cerium and lanthanum are placed in the same slot, isn't it? Two elements are in the same place. Okay. So that was in order to fit elements into his table, Newland adjusted two elements in the same slot. Example, cobalt and nickel, cerium and lanthanum. Okay. Moreover, cobalt and nickel are placed along with fluorine, chlorine, bromine, etc. Isn't it? They are non-metals. Cobalt and nickel are metals, right? So their properties are entirely different. Cobalt and nickel does not show any property similar to these elements, right? And the element which shows similar property with cobalt and nickel is iron. And iron is placed far away from cobalt and nickel. So due to these reasons, Newland's octaves was also discarded by the world of science. Okay. One more periodic table is there before coming to the modern periodic table. This is modern periodic table, that is Mendeleev's periodic table. So we will meet again with Mendeleev's periodic table first, then we will come and discuss what are the important properties of the modern periodic table. We will get familiar with the modern periodic table first, then we will go to discuss the properties. Alright, so today's class is over. Hope you understood very clearly Dobereiner's triads and Newland's octaves. Watch the video twice, then you will understand it very clearly. We'll meet again in the coming class. Till then, take care and bye-bye. Thank you for watching.